Okay, so just going to go over the gizmo quickly. We were able to get through most of this in class, but you did need to finish a little bit for homework, and this will be helpful if you missed class for those that weren't there. So the first three questions are prior knowledge. So these three questions should be easy to answer. A pot filled with snow is left on the stove, so the snow is going to turn to liquid. The phases that you would see, snow is solid ice crystal, so it's a solid, and then turning to regular water, that's a liquid. And the phase change that we would see would be melting. Okay, and then so for this, you're going to have to go back and forth with the gizmo, but it looks like the first one looks like this, and it's the one that says phases of water. And you start out in this section, it's all liquid water in the beginning. And you click heat, and you want to heat it up until the temperature stops going up. And the temperature stops going up at 100 degrees Celsius, and then it says boiling. And the liquid water is changing to water vapor at that point in time. And the lid on the container's going up because it's filling with water vapor, and the liquid water is going down because it's changing to water vapor. And that whole time, the temperature is staying at 100 degrees Celsius. Okay. So what is making the lid go up? And that would be water vapor. And then if we press chill to remove the energy, the thermal energy, you'll see the lid go back down. The temperature will stay at 100 though. It'll say that it is condensing. So earlier we were boiling and now we're condensing. The water vapor is going down, and the liquid water is going back up because the vapor is turning into liquid. Okay. At what phase is water at negative 20 degrees Celsius? That's going to be a solid that is ice. At 30 degrees, it is liquid water, and at 105 degrees, it is gas or water vapor. So how does the temperature affect the phase of water? As you add energy, the temperature will go up until it reaches a phase change. Then during a phase change, that temperature doesn't change until the phase change is done and it is completely in the other phase, and then it keeps going up. If you're removing energy, the temperature will go down until you reach a phase change, and then it will stay at that temperature until the material is completely into the next phase, and then it will start decreasing again. Observe at what temperatures these specific phase changes happen. So melting happens at 0 degrees Celsius. Boiling and condensing both happen at 100 degrees Celsius. And freezing happens at 0 degrees Celsius. So what do melting and freezing have in common? They both happen at 0 degrees Celsius. While you're watching something melt or freeze, you will see both of the solid and liquid phases present because it's in the process of going from one phase to another. So a phase change is when you're changing phases from one to another. So you'll have two phases present. Like if you set an ice cube out on the counter and it begins to melt, you're still going to see some of the ice cube, and then you're going to see a puddle of water forming. Okay, so you're going to see the solid ice cube and liquid water both until the ice cube is done melting. When it's finished melting, then you will only see liquid water. But while it's in the process of a phase change, you will always see two phases present. So boiling and condensing, what they have in common, they both happen at 100 degrees Celsius, and they both have gas, which is vapor, and liquid present. While something is boiling on the stove, you can very clearly see the liquid. bubbling. And then you can see the steam rising. So you can see the liquid and the steam both at the same time. That's while it's in the process of boiling. And you can say the same thing about when it's condensing in the process of going back into the liquid phase. In which two phase changes does the energy need to be added in order to occur? So that's melting and boiling. And then the other two, when energy is being removed, are freezing and condensing. And then you need to switch gizmos to phase changes, and you'll need to use that gizmo as well while you're answering this. You can pause this whenever you need to go back to the gizmo. But I'm just going to explain the answers real quick. So set up the gizmo to observe freezing. What do you notice about the temperature while the water is in the process of freezing? While it's in the process of freezing, the temperature stays the same at 0 degrees Celsius. It does not change until the whole beaker is frozen. What states of matter did you observe in the container during the process of freezing? So again, this is what we talked about up here. While it's in the process of freezing, you will see both water and ice. You'll see both phases. Think about when you put an ice cube tray in the freezer. If you take it out before everything's frozen, you're going to see some ice on top, but you might be able to see some of the liquid water still underneath where the ice cubes aren't completely frozen. So while it's in the process of freezing, you're going to see two phases, both water and ice. Use the gizmo to investigate melting and boiling. What do you notice about the temperature while the water is in the process of melting? So again, it's going to stay the same, and melting happens at 0 degrees Celsius. So the temperature is not going to change while it's melting. It's going to wait until the water has completely melted from ice to liquid, and then the temperature can increase again. Number 4, observe what state or states of matter did you observe in the container during the process of boiling? Remember, boiling happens at 100 degrees Celsius. You would see both water and gas. Two phases during boiling. During the process of boiling, you would see both liquid water and gas or water vapor. So, based on questions 1 through 4, you can conclude what can you conclude about the temperature during a phase change? A little typo there. So during a phase change, the temperature stays the same. It does not change. Even though you are still adding heat or taking heat away, you're still either adding energy or removing energy, that temperature stays the same during a phase change. And we're going to talk more later about what the energy is doing. If it's not increasing and decreasing the temperature, it's still doing work, but it's just doing something else with the molecules. Interpret. Select the graph tab. So you're really going to need to look at the graph and do what this says to see that. But during a phase change, so while it's, you could set it up for boiling, since you would have already done that in the previous question. So the water was heating up, and then the water stopped heating up and it was boiling. And so while it was boiling, sorry, let me change color. So while it was boiling, the line is flat. It's a horizontal line during a phase change. That's because temperature is on the y-axis. And if the temperature is not increasing or decreasing, you're not going to have a slope. So you're going to have a flat line. What states of matter did you observe in the container while the temperature was increasing? So if the temperature is increasing, that means it's just during a phase and not during a phase change. So you would want to look at, for example, if it's all liquid water, so that would be somewhere between more than 0 and less than 100 degrees Celsius. Somewhere in that range, you'll have liquid water. And you can watch the temperature go up and down. And during that time, you're only going to have just liquid water. Or you can do that when you have all ice in the container. You know, before you reach the melting point, before you reach 0 degrees Celsius. I don't remember exactly the lowest temperature that the ice can go in the Gizmo that you can set it to. But you can set it below 0 and warm it up to 0. And then the temperature will increase. And then if you were below 0, you would have just ice, just a solid. But in the range of 0 to 100, you have just water. Based on question 7, you can conclude what about the temperature during a phase. So during a phase, the temperature can go up or down. Okay, until you reach the temperature of the next phase change. So while it's all liquid, the temperature can go up and down. Select the graph tab to see the graph temperature versus time. Click the minus button so you can see the whole graph. What does the graph look like during a phase? So during a phase, so for example, this is when it was all liquid. If you're adding energy, over time, if you're increasing your energy, then you would have a positive slope. Your graph is going to be going up. Okay, and if you are removing energy, if you're cooling it down, then the graph would go down. It would have a negative slope. Why do phase changes occur? So we're down here now. Select water temperature at 0 degrees, click play. Set the water temperature to 100 degrees and click play. What do you notice about the molecules? So the molecules, it's not a huge difference, but they do move faster at 100 degrees than they did at 0 degrees. So if you weren't able to see that, I want you to go back and look at it again and watch them at 0 and watch them at 100, and you'll notice that they do move faster at 100 than they did at 0, if you were struggling with what we were looking for there. Click reset. The mean, I think it actually says average in the Gizmo now. Maybe it used to say mean, but mean means average. So the average molecular speed of the molecules is displayed below the container, kind of like to the bottom left. Set the water temperature to 0 degrees and add remove energy to 400 joules per second. Click play. How does the average speed of the water molecules change as they are heated? So the average speed is going to increase while we are adding energy until it gets to 100, and then that's during a phase change, and then it stays steady at whatever speed that they were moving. But it's going to increase. How is temperature related to the motions of molecules? The higher the temperature, the faster the molecules are going to move. So if you increase temperature, you're going to increase the speed of the molecules. Use your theory to explain what happens at the molecular level in each of the following situations. Also list the temperature at which each transition occurs. So ice is warmed to melting point. So if you've got ice below 0 degrees and you need to get it to melting point, that happens at 0 degrees Celsius. And the particles are going to speed up. Remember, ice is a solid, and during the solid phase, particles don't move very much, but they have a slight vibration. And so they're going to be vibrating more the closer you get to 0. Okay. Water is warmed to boiling point. So again, particles are going to speed up, boiling point happens at 100 degrees Celsius. Water is cooled to freezing point. That happens at 0 degrees Celsius. And then if you're cooling it, you're removing energy, the particles are going to slow down.